Now we're going to see how to convert a galvanometer to ammeter. So about ammeter, you can read this. You'll understand what is ammeter is about. Now let us concentrate only on conversion of a galvanometer into an ammeter. So now let us observe the circuit diagram here. So we have a galvanometer here connected, and so we have a resistor that is denoted by S. And what is the connection here? We are connecting a resistance parallel to the galvanometer. Okay. So here the galvanometer offers some resistance. Okay. Inside the galvanometer there is a coil. That coil offers some resistance to a galvanometer that is denoted by G. So now we can consider there are two resistors connected in parallel. One is the resistor, which is a resistance which is present in the galvanometer, and the resistor that we have connected externally, that is denoted by S. Now, so this is a current, which is the total current which is flowing through the wire. So here it divides. So some part will flow as a Ig, as the current which is flowing through a galvanometer, and another some part will be flowing through the resistor S. Okay, so this total current is getting divided into Ig and I minus Ig is the current. So now let us see how we are going to describe this circuit diagram. In the circuit diagram, we can see S is the low resistance, G is the resistance of a galvanometer, I is the maximum current which is flowing in the circuit, and Ig is the current for a full scale deflection in the galvanometer. In this case, the galvanometer and the shunt resistance are connected in parallel, that we already know. Now what we have to do at this point, okay, the potential difference at this point will be same. That means across the galvanometer and across the resistor, the potential difference will be same. So that is what we have written here. The potential difference across S, that is equals to potential difference across G. So now we know from the Ohm's law we have V is equals to I into R. The potential difference, that is equals to I into R. So instead of IR here, we are going to write it as for a resistor. Okay. So instead of I can write it as I minus Ig. The current flowing through the resistor is I minus Ig. And what is the resistance present here? It is denoted by S. I minus Ig into S. That will become the potential difference across a S. And at the right hand side, we have for a galvanometer. So what is the current flow through the galvanometer? It is Ig. So instead of I can write as Ig. Instead of R, what I can write as G. G is a resistance in the galvanometer. Okay, so we got this equation. So it is like I into R, here also in the left hand side, here also I into R. Okay, but this is for the resistance which is connected here, and this is for the galvanometer. Okay, and we need to know what is the resistance, the small resistance we need to connect across the galvanometer or parallel with respect to galvanometer. So what I do, I'll retain this S here itself. I'll shift this to the denominator so that I get the final answer, that is S is equals to Ig into G divided by I minus Ig. So this is the resistance, shunt resistance we call it as, that we need to connect in parallel with the galvanometer to convert a galvanometer into a ammeter. So now let us learn about how to convert a galvanometer into a voltmeter. So here you can see the circuit diagram. We are converting a galvanometer to voltmeter, so that we are going to connect a resistor, okay, the high resistance in parallel, in series with the galvanometer. Okay, this is the series connection. Okay, so we are connecting in series with the galvanometer. So galvanometer can be converted into a voltmeter by connecting a resistance in series with it. Okay, so now what happens to a total resistance here? The G represents the resistance present in the galvanometer. R is the external resistance that we are connecting with respect to galvanometer. So now in the circuit diagram, R is the high resistance, G is the resistance of a galvanometer, Ig is the current for a full scale deflection in the galvanometer. V is the maximum potential difference to be measured. From Ohm's law, we have V is equals to I into R. So what is the total resistance we have? That is G plus R. It will be a total resistance. So instead of just R, we are writing as G plus R as a total resistance. What is the current which is flowing? here, that is Ig. Ig is the current which is flowing through a galvanometer. So we write it as Ig itself. So we need to find out what is the resistance R. We need to connect along with the galvanometer in series to convert a galvanometer to voltmeter. So now we have we want to know what is R. So we'll keep G plus R here itself. We'll shift Ig to the denominator. So what I get, G plus R is equals to V by Ig. That is what I have written. G plus R is equals to V by Ig. And we need to know what is the R, that is the I resistance to be connected with respect to galvanometer. Okay. So what I do, I'll just shift this G to the other side of the equation. That G will become, when it goes to other side of the equation, it will become minus G. So we get R is equals to V by Ig minus G. So this is the resistance we need to connect in series with respect to galvanometer to convert that galvanometer to voltmeter. Thank you.